Question 1. Calcium carbonate is an insoluble solid. Calcium carbonate can be made by adding excess aqueous calcium chloride to aqueous sodium carbonate. Here is the equation, and here you see, guys, we see that the substance is in excess, which is, this is excess, take care. Aqueous calcium chloride, which is this substance, is excess. And of course, when a substance in reactant is excess, so it means the second one is limiting reactant. So this one is going to be limiting, and this is excess. It means by the end of this reaction, we're going to see this substance goes to be used up completely. But the first one, CaCl2, because it's excess, so it's supposed to stay in the reaction. Okay? Here we have a student makes a sample of calcium carbonate. The first two steps of the method are shown in figure 1.1. So here we have the first two steps. Step 1, as you see, we add excess aqueous calcium chloride to aqueous sodium carbonate. And take care, guys, here we have, this is aqueous sodium and this is aqueous calcium chloride. It means both of them are already dissolved in water and they are aqueous solutions. And in step 2, actually we stir the mixture by this tool, as you see, which is A. So question A, name the item of apparatus labeled A in figure 1.1. So of course, guys, I think everyone knows in our chemical lab, we use a glass rod. Usually we use glass rod to stir. So the first one could be a glass rod. This is a glass rod, okay, to stir the solutions. Letter B, suggest why the mixture is stirred in step 2. Here, guys, we said little early that the two solutions are already aqueous, so usually we dissolve the solute in the solvent, but now both of them are already aqueous and they are dissolved already. But actually we stir in order to mix them together. After we make them together, also you know that stirring usually increases the rate of the reaction. So here the answer could be, we say, to mix the solutions, so the rate of the reaction is faster. Okay, so the main purpose for this is to mix the two solutions together, and also the rate of the reaction is going to be faster. Okay, letter C, after step 2, the student filters the mixture to remove the solid calcium carbonate formed and collect the filtered. You know, guys, the word filtrate here means soluble substances in the solution. This is filtered. So the soluble part of everything is the filtered. And the part which is, you know, like filtered already, which insoluble, is called, you know, residue. So we have something called residue, which is insoluble part. So this residue is solid and it's insoluble. So after doing this, we have two parts actually, the filtrate, which is the soluble solution, and we have residue, which is the solid insoluble part. So here again, draw a label diagram to show the apparatus used for this filtration. I think this is very easy drawing, but we can do it together. We need to start by the funnel. This is filter funnel. Of course, you can control better than me. So here inside we need to draw also the filter paper. So funnel and filter paper, and finally we need also to label the shape, and here we need also to stand the funnel over a container. So we could use, for example, a conical flask. So here also we need to show the filtrate. Now let's label everything here. So this is actually, this is the filtrate, so which is the soluble part, And here we have, don't forget to draw here, actually guys, this is the residue or the insoluble part. So take care, this one is called residue, which is solid or insoluble. And here, this is the funnel. And you have also to refer to this is filter paper. Okay, guys, this is filter paper. So now your diagram is full. Next question. This is the solid calcium carbonate obtained by filtration is not pure. So here we talk about this residue. Actually, this residue now is CaCO3, which is solid. Here he say it's not pure. Okay, so identify one substance other than water. So we need to skip water from our answers, which is mixed with the calcium carbonate and makes it impure. If we come back again to the equation or the mixture of the reaction, but let's come back to the equation itself. So here actually this substance is limiting, which is supposed to be used up after the end of the reaction. So this is not found, this one not found, so we can cancel it. So after the reaction we have this solid, the basic residue, and we have mixture between sodium chloride and aqueous calcium chloride. So we could write any one of them. That makes the calcium carbonate is impure. So the two substances here you have up again, calcium chloride or sodium chloride, because they are mixed. So this is either calcium chloride, okay, CaCl2 aqueous, or you could write also the sodium chloride. Okay, you could write this or this. Second one, double I, describe how the substance you have identified in Di, which is this substance, can be removed from the calcium carbonate. So again to the drawing, how can we remove this residue or calcium carbonate, which is solid? Actually, it's contaminated with some calcium chloride or sodium chloride. So I think the easiest method is to add the distilled water to rinse this residue. So now it's pure. So the answer here again, so we need to pour or to add distilled water for this residue or the calcium carbonate solid, so we can rinse and make it clean. Okay, we could say rinse the residue by adding an amount of distilled water. So now we can make the residue pure after cleaning. Letter A, describe a test the student can do on the filtrate contained in C to show that the calcium chloride used in the excess gave the result the student obtained if the calcium chloride is in excess. So here we need to make sure that calcium chloride we used at the very beginning was in excess. So we need to make what is the test and also what is the result. So the substance here again, guys, this is called calcium chloride. Of course, by testing anything, we need to check two parts. In calcium chloride, we have a cation Ca2+, and we have Cl-. So here we have 2, and here we have this is 1. So to check this, guys, we need to check chloride anion or calcium cation. But actually, we can't check chloride here because also we have in the product, this is NaCl. So we have here also Na+, and we have Cl-. So Cl is repeated, so we can't make sure this Cl is related to calcium chloride or for NaCl. So actually, test for amine Cl now is not available. Okay, so we can test the presence of calcium. Okay, and for this reason, we could use the test which is already in your paper 6, and this is very good point to have this. So here, guys, you check, this is calcium test, this is cation calcium. So we can add here, if you check here, So we could add aqueous sodium hydroxide. So if a white PBT, which is insoluble in excess, so the cation is calcium. So this is one method or one way for your answer. Actually, we have another way by making sure that no Na2CO3 actually here. And this is easier, by the way, we can write it down also. Because we said this is limiting, so theoretically it's supposed to not found by the end of the reaction. So if we check the presence of, look at this anion, which is here, this anion is CO3 2 minus. We can check for this anion, this is minus. Okay, so we check for the carbonate by adding acid to reduce carbon dioxide. So if we check this carbonate anion, if we have carbon dioxide which make like effervescence or fizzing, so it means we still have this. If we have a negative result for the test, it means this substance is limiting and already the calcium chloride was excess. Okay, so let's say by adding an acid or by adding, here the test is by adding an acid, for example, let's say hydrochloric or whatever, so HCl. This is aqueous diluted acid. So the result, because the result now should be negative, so negative means no carbonate, so we could say no effervescence, or also you say or no fizzing. So it means no carbon dioxide or no carbonate, so no, the substance is already used, so actually the substance was excess, actually it's calcium chloride.